Today we're going to be looking at the equations of lines in the coordinate plane. Everything I'm going to talk about today you have seen before in Algebra 1. The important thing about today is to kind of refresh yourself on some of the stuff that you've done because it's been several months since you've had to do it, because we're going to be learning something new in the next couple of days that you're going to need this for. Okay. Also, I know in Algebra 1, we talked about how the way you wrote things wasn't quite as important. And now that we're in geometry, the way we write things and communicate math is what's important about this class. So make sure you're paying attention to the way I write the lines, notation, the way I write slope and the notation, because that's what I'm going to expect from you when you do your homework and on our tests and quizzes. So it should be very, very similar to last year, but there may be just a little bit of extra notation you may need to pay attention to. Okay. So first of all, just a quick refresher. The slope of a line when you're on a coordinate plane describes how steep the line is. So any 2 points can be used to make a slope. Okay. So if I give you a graph, you can just do the rise over run. So if you remember just counting, so if you start down here at this bottom point, see the dot on the left, and you go up 6, that's the rise. Go over 4, that's the run. We always go left to right when you're doing rise over run. Okay. Never go right to left. Always do it like you're reading, left to right. If you go down, the number is negative. So that's one thing you're going to want to watch for when you add that negative sign. If I don't give you a graph, you're going to have to go back and do the slope formula. That may have been a little while since you've had to do this formula. So m equals y2 minus y1 over x2 minus x1. The important thing is the pieces right here come from the same coordinate point, and then the x1, y1 come from the same coordinate point. So as long as you put those together, one right above the other, it doesn't really matter which coordinate point you choose for your x1, y1 and which one you choose for your x2, y2, but make sure you keep them vertically aligned to each other. A quick review here of slope of a line. So positive slope goes up, negative slope goes down like you're skiing. Zero slope is horizontal. Vertical slope is considered an undefined slope. Okay. I don't know if any of you have ever seen slope face before. Your junior high teacher may have taught you about it, but you have the positive slope, you have a negative slope, you have an undefined slope, and then you have an undefined slope. So we can add this little piece, and then you have a zero slope. You can put 0 underneath it. So if that helps you remember, just making a silly little face, that the straight up and down is undefined and the horizontal is 0, use it. Okay. It's just kind of silly, but hey, but it does work. Okay. So here's where it may be a little different from last year. Is last year you were just given one line on a picture, but now that you know how to read notation for a line, I can give you several different lines on the same picture and then ask you to determine the slope of each line that's there. So this first one we're going to look at is AB. So it is line notation. Notice I didn't put segments. Okay, it does have those little arrows on the end. I am specifically asking you to use the slope formula. And the reason is because I want you to practice with that. All right. Now, after this, if I give you an option, if it doesn't say specifically to use slope formula, you are welcome to use rise over run. That is always an option, but we're going to need the slope formula later this week. So I just want to make sure we have it down, even though the graph is here. Now, the nice thing about having the graph is we can also check our work by doing the rise over run. So if I first notice point A over here to the left, and I need to go all the way over to point B, I notice right away this is a horizontal line. So if you think about what I just told you about slope face, this should have a 0 slope. So if I work out slope correctly, my answer should be 0. Okay. So our 2 coordinate points, if you need some help remembering how to label things, we go left. So the first coordinate point is an X point. So it's -2. And then I went up 7, and that's how I get the coordinate for A. Okay. So I decided that's going to be my X1, Y1 because that's on the left. It's easier for me just to think left to right that way. And then point B, you go over 3 and up 7. And that's how I got that coordinate point, right? So I'm going to make that my x2, y2. To plug those into slope formula, make sure in this class, everything has a label. So when you're going to plug in for slope, you're going to put m equals, and this has to be a little m. Remember, we've used a capital M this year for midpoint. So the little m is what tells us it's slope. Those are different things, so we have to have a different label. So when I plug those pieces into the formula, it's going to be plugging into this right here. Okay, and so you can kind of match up your x1s and your y1s and your x2s and your y2s, and it should look something like this. Now, I know some of you can go ahead and think in your head that it's going to be 3 minus a minus 2, and that's just going to be 3 plus 2, and I'm okay if you want to write that down. I just thought of the notes, it might be helpful to go ahead and put it as a minus so that you remember that the formula itself is always x2 minus x1, okay? So set your formula up, and then we're going to reduce it. So make sure you're always writing that fraction bar underneath both pieces, okay? And kind of like we've done before, as long as you keep your equal signs in a line, then it's okay if you don't keep rewriting the m every time. When I simplify this, I'm going to get 7 minus 7 is 0, and 3 plus 2 is 5. And 0 over anything is just 0. So that is my answer. So that's exactly what I thought it was going to be. So I know I've done it correctly. All right? So that's what we're going to try. Let's try another one. So this one I've got is AC. So if you look at AC on the picture, AC is sloping down. So I know my answer, if it's going down, should be negative. Okay. And so let's try this one again. Sorry, my button's not working. And so I've got A is negative 2, 7. C is 4, 2. So when I plug these in, I just chose to make the C the x1, y1 and the A to make the x2, y2. Did that matter? Not at all. Those were just my choices, and I wanted to put them on the screen so you know why I plugged things in where I did when I go over here to the slope formula. So when I plug those in, you're going to see something like this. So 7 minus 2, this 2, it's the two blue numbers that you see on the screen that are on the top. So now there's a repeated 2. And then it's negative 2 minus 4. So just be careful with your positives and negatives here because that is a negative 2 on the bottom. So when I subtract, you're going to get 5 over a negative 6. Okay? And that's my answer. Now, it's okay. It's okay if you leave your answer like that. I know you had algebra teachers that told you different things. It is also okay to put the negative sign out front if you want to write it this way, if you prefer. That is an okay answer too. You can also put the negative in the top of the answer. It really doesn't matter in geometry where we leave your negative. I know some of your algebra teachers had a preference, but in this class, that is one thing that doesn't matter. Okay, last one. I'm going to encourage you to pause the video for a second and try this one on your own just to see if you can set it up and figure out the coordinate points before I go through it. And then I hope you've tried it. And let's see what you get. These are the two coordinate points I used. I used negative 2, 7 and negative 2, 1. Okay, hopefully you got those two. Again, you may have plugged yours in, your x1 and x2, you may have used differently. You may have labeled those differently, but our answer should be the same. I plugged the points in as you see on the screen. So I did 7 minus 1 and then negative 2 minus a minus 2. So negative 2 plus 2. So I ended up with a 6 over 0. And no matter which way you set it up, you should have ended up with the same thing. You may have ended up with a negative on the top if you flipped your numbers around, but it doesn't really matter because if I have any number over 0, that's always undefined as your answer. Okay, so that's the word we're looking for. So if you see something over 0, you're going to say your slope is undefined. Now, I know one question you're probably asking is, do I have to write down the formula every single time? No, you do not have to. I'm okay if you jump to the numbers first. Just make sure you label that first part with the numbers with an M if that's how you choose to do it. Okay. But I always recommend writing down the formula if you're having trouble memorizing things. And if it's been a while since you've done slope, you might want to write it down just to help you remember it. But it's okay if you don't. All right, one more thing we need to review is putting things into the equation of a line. Okay, I know I mentioned this to some of you the other day, and you really quickly knew slope-intercept form. That one sticks with a lot of people. So hopefully that part comes pretty quickly. So y equals mx plus b, remember the m stands for slope. That's why we've been using that little m for every slope we've been solving for. And b is your y-intercept. So it's always a coordinate point of 0 something, okay? But we're also going to be using point slope some this year. The farther you go on in math, the more point slope actually becomes helpful. So I know a lot of you probably didn't like point slope last year because y equals mx plus b just feels nice and pretty and easy to do. Well, point slope actually isn't that much different. So what you have to do with point slope is all I need is a point. I don't actually have to have the y-intercept. So it's a lot easier to use with different information. Okay, we're going to consider point slope sometimes the finished product. I'm not going to ask you to change everything into slope intercept form because I want you to get comfortable with point slope form. Okay, so the other couple of things I want you to look at is the equation of a vertical and a horizontal line. Everybody always gets these mixed up. I don't care if you are in Algebra 1 or you are in Calculus 2. Everybody always hesitates when they're trying to figure out which one is vertical and which one is horizontal. Well, if it is a vertical line, it's an x equals because it means that line is going to cross the x-axis. That's the easiest way to remember. Which axis does the line cross? And that'll tell you which variable to use. So a horizontal line will cross the y-axis, so we say y equals something. The other way I think is kind of silly to remember it is if you're doing the YMCA, but you do a really lazy YMCA and your arms are really wide, then you end up with a horizontal line. And that's just a really dumb way to think about y equals as being the horizontal line. It's kind of silly, but it can work. So let's try an example. Let's write an equation of each line that I give you, and I'm going to tell you which form. So you've got to read the instructions carefully on your homework tonight, whether I say slope intercept, okay, or whether I say point slope. So this one, I'm going to specifically tell you that the slope is 4, and I'm going to specifically tell you the y-intercept is -5. So that means your m is the 4, and your b is, I left off a negative there, and your b, try by drawing a little negative there, is a -5. So since I have both the m and the b, I can immediately plug this one into slope intercept form, which is, remember, just y equals mx plus b. Okay, so I don't expect you to write down the formula. I know you all know y equals mx plus b form, so that's the form you're going to plug it into. But just in case you've forgotten what I plugged it into, y equals mx. So I cannot draw. Is y equals mx plus b. All right, let's try one more here. So this time I want you to write the equation of the line in point slope form. So again, read carefully. I've given you a slope and I've given you a point. So you have m. That's what this is right here. But I did not give you the b. So this is why we like point slope. It's a whole lot easier to use. I don't have to plug in, solve for b, and then write the equation again. I've got a point, I've got a slope, and I can just plug it straight into my equation. Okay? And so the way the equation is written, you're always going to plug it into the second variable is where we're going to go, the ones that have the little subscripts. Okay? So the x1 is your 3. The y1 is your -4. And so we're going to plug those in. And the m is your 6. And so we're almost done. We're not going to have to do a lot of rewriting since I want it in point slope form. But the main thing I need to do is never leave a double negative. So it's totally fine to write it with the double negative just to help you make sure you get your plus and minus signs right. Okay? But make sure you don't leave your answer like that. I want to simplify it down to y plus 4. And that's it. Do not distribute that 6. Leave it just like you see it. That is point slope form. It's so tempting to want to solve for the y because that feels very unfinished, but that's your answer. Okay, one more here, a little bit more to this one. And you did these a lot last year, I know. I want you to find in slope-intercept form again, okay? And I'm going to ask you to find the equation line through the given points. Now, I didn't give you a slope. I also didn't give you the y-intercept if you'll look at it. So there's a little bit more work to do with this one. This means I'm going to have to set up the slope and get it myself, right? But you know how to do that. It just means the problem's going to be a little bit longer than it was before. So if I set this up, I'm going to look at this one and say that this first point is my x1 and my y1. And the second point is my x2 and my y2. That's my choice. And so I've told you that if it helps to label things above, go for it. And then this is how I plug it in. Okay, if that's my choices, then it's 2 minus 0, and then 1 minus a minus 1. So I'm going to get 2 over 2. Well, that's just a slope of 1, which is nice and handy. That's pretty easy to use, right? Now, even though I asked for slope-intercept form, the easiest way to do this problem is to start with point slope, okay? So here's where you get a little bit of a choice. I have to use the 1 for my m, and I'm going to plug in a point for the x1 and the y1. But you get to choose whether you want to plug in the 1, 2 or the negative 1, 0. Both are correct. Okay? When we solve it for slope-intercept form, we will get the same answer either way. I looked at it and said the first one has a 0, so I'm going to go with the one that has a 0 in it. That's a little bit easier to solve. That was just my choice. Okay, so when you plug in the 0 for y1 and you plug in the negative 1 for the x sub 1, your equation looks something like this. When I simplify, the left side is already solved for 0, and the right side, I can get rid of the 1, or you can leave it. It doesn't matter. And so x plus 1 is how that simplifies, and that's my answer. Okay. So I said there's nothing wrong with leaving the 1 in front of it. I just don't need it because there's always an understood 1 in front of an x if there's no other number. So our goal today is to really get used to point slope form. Even though you've seen it, we want to get a lot more comfortable with it. All right, I have one more for you that's going to be solving. And so this one I want to find in point slope form. So again, we're going to leave it in that point slope form. That was a really bad straight line. Sorry about that. But I'm going to give you the x and the y intercepts. Now, I want you to star this problem in your notes. I may not be there, but I still want you to star this in your notes. This one is you're going to see a lot. And so you can actually, with the x and y intercept, you can get 3 points. One of your points is going to be with the x-intercept is going to be over 3 and up 0. Every time you're given an x-intercept, that's the form it'll take. You put the number, comma, 0. Your y-intercept will always be in the form 0 and then whatever number you're given. So if I say intercepts, you can automatically get yourself 2 points. All right, and you're gonna need that tonight in your homework. So once I have those 2 points, this problem becomes exactly like the last one we did. When I plug it into slope, I'm going to take negative 5 minus 0, 0 minus 3. The zeros make it easier to solve, but watch your positives and negatives because you actually end up with a negative over a negative. So those are going to cancel out and give me a slope of 5/3. Again, the next step, it does not matter which point you choose to plug into the point slope form. Even though I'm going to leave it in point slope form this time, that's totally okay. We will get different answers, but both are correct. So I looked at it and I said, well, let's just use the first point listed and use the 3, 0. So I'm going to plug in a 0 for the y, and I'm going to plug in a 3 for the x, and it looks something like this. Now, technically, that answer is completed because I'm in point slope form already, but we don't need the 0. So sometimes we go ahead and reduce it and get rid of that 0. Okay. I'm okay with both forms because I know sometimes this is a little bit easier to see what's going on. This way feels like you're close to y equals mx plus b, but not exactly. But both of these, this is an acceptable point slope form. Do not distribute the 5/3 if I say point slope. All right. So hopefully that refreshes your brain on how to solve an algebra problem. And so now I want to look at a little graphing. Okay, see if we can remember how to do some graphing from last year. You're not going to have to do a ton of it, and I'm going to give you the graphs on your worksheet, so it's all going to be there for you. So if I say to graph the line y equals -3, immediately I notice that this is either going to be a horizontal or vertical line. So what we said earlier is that if you see y equals, think about what is that going to cross? Well, that's going to cross the y-axis because it says y. So the only thing that's going to cross the y-axis has to be a horizontal line. Okay, it's going to cross at that -3 point. That's how we know. So that means every y coordinate is going to be at -3 on that line. So how do I expect to see you draw a line? Well, when you graph, I expect to see straight lines. I don't want to see wobbly horizontal lines. So you grab your student ID to draw the line. Whatever you've got handy, just grab another piece of paper to help you draw the line, but your line should be straight. Okay. I need you to graph 1 point on that line to kind of show me where it is. So the 1 point I know is that intercept is 0, -3. So give me 1 point, and then make sure you do put arrows on the end of your line. So we're going to try to clean up maybe some things that you didn't do last year so that we are all on the same page with graphing. And when you get to Algebra 2, graphing is a little bit more complicated. So I want to get you some of the basics down now so that you're really comfortable when you get to Algebra 2. All right. Okay, here's another one. This one, we're going to graph the line y equals 2x minus 3. So on this one, you've got the m here with the 2. And so I can rewrite that, as you see down here a little lower. I rewrote it as 2/1, so we can see the rise over run. Anytime you just have a number, you can always know there's an understood 1 underneath it. And a lot of you are pretty good at remembering that. Because it's in slope-intercept form, I can see that I've got the b, but remember the sign goes with the b, so that's why down here it is -3 and not +3, right? So to graph, I'm going to go ahead and pop the graph on here, and then I'm going to explain it, okay? I'm going to graph the y-intercept first, so that's the point I want you to graph and label. So I graph the b. The b is 0, -3. So graph that first, and then you can use rise over run up to over 1 to get another point, and then put a dot there. Okay? I'm not going to make you label that one, but it should be a very, very clear dot there. And then again, use your student ID or something. That arrow doesn't show up too well. To make sure you've got a straight line, and make sure you put arrows on the end of that line. So always graph the y-intercept first, and then use rise over run to get yourself a second point. Okay, so if this is a slide you might want to pull back up if you're having trouble remembering how to graph. This is a good example. Okay, I've got one more for us, okay, because this one's in point slope form. And that's okay. I can graph sloping in point slope form as easily as I can in slope intercept form. The m is given to you. It's right here. We got that in the last one. But rather than me having an intercept, I'm just giving you a point this time. And your point comes from these two numbers right here. Your x is the opposite sign of what you see there, okay? So if you need to write yourself a note, that's going to be a -2. And then this one has the exact sign of what it does for the y. The y is just 1. Because remember, the formula is x minus x sub 1 and y minus x sub 2. So because that sign's changed, that's how I know I'm going to use the opposite sign. So I recommend before you graph, and I'm going to ask you this on several homework problems, to specify what m you're using and then specify what point you're using. So I may not have the the B this time, or the y-intercept to graph, but I still always start with that point that I'm given. So I'm going to start graphing this one at -2, 1, and then I'm going to use the slope given with a rise of -2, which means I'm going to go down, and a run of 3 to graph. So go ahead with the instructions on the screen, pause the video again for a second, try it on your own, and then we'll see how you did. Okay, here's the graph I have. Sorry, my -2, 1 slid over a little to the left. Try to keep your points labeled a little closer than mine is. It's just a problem with the PowerPoint. Couldn't get it to go where I wanted it to go exactly. But notice I went down -2 and then over 3 when I went and graphed my line. Okay, so hopefully that all is kind of clicking, and I will see you tomorrow.